Alrighty, what's going on? Math teacher. I'll call you Mr. Rad. That's pretty fitting, isn't it? So, I have a script here. It's in my little hands on my phone. I could read it, or I could just, do whatever and just see how it goes. Now, I'm here to talk about math again. Mr. Rad, if you didn't know this YouTube channel I do, I used to do a lot of math stuff on here for Project Wonder years back. So it's pretty cool to be able to make a video project again. But today I have to talk about, in specific, a bunch of different terms. Oh, first of all, we're doing section 1. My buddy, Mr. S, or you can call him Mr. M, the guy who sits next to me in the front of the room. He's doing section 2, I'm doing section 1. So we're both partners. And I got to talk about common tangents and how radius plus tangents equal perpendicular. And finally, tangent segments from a common external point. Boom! Oh, and I have a PS here. So to save myself time and my own sanity, I'm not going to be doing like 5 examples of each, like when I have to explain problems, because I don't want to have to drive myself crazy with the editing process. So, if it's alright, I'll be doing 1. And as a PS for anybody who may not be Mr. Rad, I'm not a math teacher, so if I do something wrong, I do something wrong. I'm no perfect individual, that's for sure. Alrighty, let's get started, shall we? I'll stand over here, well, I'll stand here. That'll work. Alright, so what are we going to start about with the first term? This is vocab section 1. We will be going with a circle. What? Oh, a circle, right? Alright, so Mr. Slade here will pop up a picture of a circle. And what I'm supposed to say here in quotations is a circle is all points the same distance from the center. Yeah. If I gotta add some extra text to make it better because I'm looking like an idiot, I'll do it. I'll do it. Term number 2 I gotta go over is the center. Center, I'll pop up another picture here. The center is the point exactly in the middle of the circle. No, really. Wow. The radius. A radius is a segment from the center to the circle. I'll pop another picture. Then we have diameter, or if you're really, really smart, diameter. It's a diameter goes across the circle through the center. It is twice the, I don't even call it size of the radius. A chord, like, isn't that like a musical instrument or something? I'll have myself pop up a photo if I'm correct. Maybe I just look like the idiot, but I'll do it just in case. But a chord, the math geometrical term, is a chord connecting 2 points on a circle. So here's your photo. When I was going over my script earlier, it's probably secant, or I wanted to say secant, but it's probably secant. Well, however you pronounce that, S-E-C-A-N-T. A secant is a line that intersects the circle at 2 points. There you go. There's your photo. I'll pop it up too. And a tangent. A tangent touches the circle at exactly 1 point. And there's another photo. Boom! There you go. There's your vocab. Could have been extremely boring, but I'm sure the editing process for that was not fun for me. Oh well. Alright, now we go on to the section 1 problems. Here we have common tangents. I have multiple different instructions here on my script, but I think I'm going to save myself time, and I'll do it with you guys. Are there pens in this map? I don't know if there are pens in this map or not. I'll cut it out if I have to, because I'm just that smart. Aha! There are pens! Where are they? Here they are. Ooh, what color do we want? We want blue. I like blue. I'm a big blue fan. Look at how cool this is. Oh, it doesn't focus. The focus is out far. Dude, it's such... Dang! It's got wood on it! Okay. Alright. Let me lock in. I'm gonna put my controller on my desk. So you're gonna see my hand out. Alright. Now you get to watch me draw. So there are two terms here. We have external tangents and internal tangents. So I'll start off with the common internal tangent. Let's say we have a bigger circle. Oh, that might be a little hard to see. We'll go with it. Let's say you have a bigger circle here, and then you have a smaller circle over here. That's not a circle. We're going with it. There's a big thing you do with the lines. I don't have another color, so I'll just do it with blue. But usually you'd have this line touch both circles, and you can maybe do little arrows. But it would... You see the picture. In my example that I got from the book that you gave us, Mr. Rad, the line is directly touching both circles. Can I erase? How do I erase? Uh-oh. I don't know how to erase with these. That's not good. How about we do this? We're going to move you inside. Look at how beautiful this house is, by the way. Would you live here? I sure would. It's actually really nice. What do you think the price is? Or the monthly cost? Probably diabolical. Second color we want, we can do... We'll do a nice pink. Pink's pretty rad. Here we are. Oh, wow, you're low. Oh! Bring you up a little bit. Aren't I such a pro at this? What if I just don't edit any of this and it's just me yapping the whole time? Wouldn't that be hilarious? Alright. Photo number 2. So the last example we talked about was common internal. Now we're going to talk about common external. Oh, I hope you can see this. It's pink. Yeah, you can see it. Okay. You have one big circle, and we can have, I don't know, a slightly smaller circle. That's like the same exact size. Imagine that one is slightly smaller. Then you'd have the line that goes across the top, and there you go. Again, you have common external above, and I can redraw common internal, which would be a bigger, smaller, and you have the line going through. Again, common external, common, that's so hard to see with all the lighting stuff in the background, common internal. Pretty simple, right? Oh, I have other problems I gotta go over with you. I have 3 more problems. Okay, we'll do that. Let me grab another color. I'll get a... Ooh, rainbow! Yeah! The rainbow has cool history. Maybe in modern humanity that's... Maybe not. But the originality of the rainbow. We can talk about Noah. Noah's pretty rad. Noah and his family in the Ark. Alright. So we have common problems here. Oh, really? It's just fill in the blank. So I'm going to write something and I'm going to fill in where the lines would go. Okay? Okay, phenomenal. Example A, we have this circle. Oh, dude, that's so hard to see. What? No, I can't do that. Let's bring you closer. Dude, that's like... Should we first person it? We could first person it. Alright, example A here. I hate that it's a little hard to see for you guys. We have the smaller, and then we would have a bigger circle. That cuts out of it. Wow, I'm such a pro at my job. So, the solution says to find 4 common tangents. Tangents basically meaning, I don't know, for the dummy term like myself would mean just like lines you can connect. You have one that can go across the top, right? It'd be probably better if I do another color. You have the line going across the top. You can do another one going across the bottom. Go out again. Then, you can almost create a nice little X here. So you can make a line going through. I know that went through the bigger circle. Don't worry about it. Oh, you're seeing the inside of my model. So you can see that other one, and you can also see another one. Wow. Like that. That's not even a point. What did I draw there? What is that? All right, there you go. So there you go. You go from what was 2 base circles, and you can make a bunch of lines going through. Again, you have the top, you have the bottom, you have the one diagonal and the other diagonal. Pretty rad, right? Phenomenal. Where are the erasers? I think the erasers are these gummy bears. What are they? What is it? What is that? What? I don't even know what this is, but I'm gonna guess it's the eraser. Yep, yes it is. All right, switch up a little bit. We'll do another color. We'll go for a nice. There we go. Great. Use my little red pen. All right, next problem. Problem B. Let me reopen my phone. 3. We're finding 3 common tangents. This time we have the circle like this, and they're actually touching this time. They're probably not. Okay, or just slightly. We'll yeah, they're touching now. There you go. So we gotta find 3 common tangents or 3 common lines between them. You're gonna have the top. You have the bottom. And in the example, this one actually goes down a little bit more. Then you also have the one that goes between. Okay? Again, top, bottom, and between. Pretty rad, right? I know. Did I lose my eraser? Dude! Talk about the most unprepared individual. The one, the only. That's my name, don't wear it out. Alright. And then final one here for the common tangents, I believe. Problem C, which we're finding 2 common tangents. Now this one, Mr. Rad, if you were to tell me, alright, here's your worksheet for the rest of class, work on it, as you have many times this year. If I were to see a problem like this, I would sit here and I'd be dumbfounded. You have 1 circle. Oh, dude, you're so far away again. I suck at this. There you go. So you have 1 circle, but the weird thing about this time is that this one, they intersect. Oh my goodness gracious. I would sit back and be like, I'm cooked. I don't know what I'm doing. When in reality, it's extremely simple. And it's just a line that can go across the top, and you can have a line that goes across the bottom. And it's that simple. Not even lying. And there's your solution. Crazy, right? I most certainly would have given up there. Alright. That's done for. Oh my goodness. Hello. Alright, we finished with that. Now, we're going to go to radius plus tangent equals perpendicular. Oh boy, right? And we're going to switch maps, and I'm going to switch an avatar to make it even cooler for you guys. Let's do it. Alrighty. This is take 2 of the Pythagorean theorem with my little thingy mabobber. So, on screen, I'm going to pop up a photo. That is literally all the work shown right there. Now, you'll notice there's a triangle. If you look into that triangle, zoom into the triangle, you'll notice there's a right angle there, right? Because you'll notice the box that little goes out. Great. We can use Pythagorean theorem to solve for the missing sides. Cool. All right, great. Let me get my phone back. Where did I put my phone? Hello? Oh, it's on the floor. I dropped my phone on the floor. I'm insanely smart, aren't I? So, let's do our math, shall we? Oh, I'm gonna have to draw like... Oh, boy. Oh, boy. Nah, we got this. I'm locked in. Alright, so we have a squared plus b squared. It's a little foggy for you guys because of my camera thing. Equals c squared. Rad, right? Good. Let's say for the example, a is 10.1. So I'll write under 10.1. Dude, this map is so much easier to work with. Seriously. And then b can be 6.7. I totally did it on purpose. Now I get to go here and I get to go 6 of. Okay, I'll shut up. All right. Then we get to follow the instructions of c equals, c being the side that we don't know. C equals, forget what that thing's called. It would be a squared, so it would be 10.1 squared plus, in the example it says b squared, which would be 6.7 squared. Okay. And then that would equal 12.2. This is still in the thing? Oh, yes, it is. Excuse me. 12.2. You see that? Phenomenal! I'll be honest with you, Mr. Rad. When I was plugging this into my exponential phenomenal source to give me all the information that I possibly could ever need, I don't know what this last part is, but I'm going to put it here just in case. If this isn't finished. I'll erase all that. So it goes furthermore. Maybe this is another way of solving it. I don't know. But it goes a squared plus b squared equals, not equals, that would be minus. So I'll just do one thick line minus c squared. Which would then be 102.01 plus 44.89 minus 146.90. I don't truthfully understand what all that means, but I'm adding there just in case. I think I could put one and one together of this being, oh, that's A, that's B. I don't know how C showed up. Maybe that's just the continuation from what we got from 12.2 and what I explained from before, where I was working it through with square rooting. That's all I got. Boom! Phenomenal.
Oh my god, bro. Oh, hell no, man. What the?
Alrighty, Mr. Rad. Now we get to finish this off with the final part. Let me grab a new color so we're like really, really cool and rad. Low key, I think I'm gonna do it in rainbow. I'm just that cool. Alright, so this will probably be the most annoying bit for me to deal with, but we're gonna get it. Alright, so this is tangent segments from common external point. Let's see what we got here. So we have, first of all, we have a little picture. I can pick up that, show that photo on my own. It's going to be a circle. You're going to see a little triangle. You're going to see it all. But I'm going to redraw it because I'm such a pro. We have the circle. I'm going to have it up the whole time as the actual photo because I'm just that smart that I decided to draw it all just for it to be removed. Right. So, Pythagorean theorem. I'm going to need to hit him with the AC squared equals BC squared. What was that? What is that? Look at how much room I'm just not using. BC squared, and then we're going to do plus AB squared. You got that? I totally got that. It's a Pythagorean theorem. Is that what we were just doing? Sure. That's what the textbook says me to do. So I'm doing it. Great. Now we can hit them with the R parenthesis R plus 50 because it's there in the picture. Look at the picture. Look at the picture. 50 feet. Remember that. And that's a square. You got that? Phenomenal. Oh my goodness gracious. Then you have to hit them with the equals, and you're going to hit them with the R squared plus 80 squared. Booyah! And that was substituting. We were substituting there. Next, we're going to multiply. How are we going to multiply? I'm going to erase it, and we're going to keep working from that. Here's my pen. You're going to then get r squared plus 1,000. 1,000 r. Why is that so blurry? What am I doing? 1,000. It's a 100 r. Oh my goodness! I'm that smart. R squared plus 100 r. You know, we all make mistakes. It's okay. Plus 2,500. Plus 2,500. Then we're going to zoom out a little bit here, so I have room to work with. We're going to hit him with the minus r squared, and then hit him with the plus 6,400. That was by multiplying said numbers. Then we have subtracting from each side. So that would then leave us with, by subtracting with each side, we'd be left with 100r minus 3,900. Okay. Then we're going to divide each side by 100. Okay. You see that? Great. So what does that leave us with? That leaves us with r equals 39 ft. R equals 39 feet. I forgot about the... I decided to not care about the feet in the beginning, but you have to remember in the end, because Mr. Rad here is very important about our very cares about our labeling, which is a phenomenal thing, so that we ourselves don't become idiots and label things properly. Because it's like 39 what? I don't know, chicken butt. Alright. There we go. That's what I got for you. That's my math. Because my math is mathing, okay? Pretty rad, right? Absolutely. I'm gonna put my phone in my pocket. That was my math video assignment for geometry. If there was a mistake that I probably made, I bet you I made a mistake. Oh well. Maybe I can come back and redo it. But I don't have to do that like Project Wonder. I remember, I forgot what it was on, but I remember I had to do that several times. I think I did it up to 3 videos because I kept getting it wrong. Diabolical. It's also back before I edited videos, so I just record it and just see how it went. I don't know how Mr. M dealt with that. I don't know. Alright, well, with all this being said, this was a blast to make. Blast to record. I mean, I haven't done this in a while, so. I mean, my last video projects were like acting or interviewing, you know, stuff like that. So this was a cool, nice little shift. With that being said, I'm gonna say bye-bye. My hands are so black. I'll do it here. Bye-bye. Bye-bye. And God bless y'all. And hopefully you learned something, I guess. Alright, have a good one, Mr. Rad. Bye-bye. La donna è mobile, qual più al vento.